So you might remember from your younger days that, if you had y equals x squared, you knew that graph looked like this. And then if I went ahead and put something in that parentheses, that was going to take that whole graph and shift it three over and mess things up for you. Same graph moved over. This is no different. This is going to take our typical cosine graph and shift it over pi over 4, which means all those places where it was hitting the x-axis, all those places where it was 1 or negative 1 are going to shift over, and I've got to figure out what those new points look like, right? So typically, we are looking at what's happening when we take the cosine of negative 2 pi, the cosine of 0, and the cosine of 2 pi. Our basic graph, when we do 2 periods, those are the 2 full periods. The one that goes from negative 2 pi to 0, and from 0 to 2 pi. So we're going to do a similar thing. We want to figure out when is this going to equal negative 2 pi, when is it equal 0, and when is it equal 2 pi. So I'm going to set that up. When is x minus pi over 4 equal negative 2 pi? Okay, that's pretty gross looking. But if I get me some common denominators, it's not the worst thing in the world. Basically, this common denominator would be, of course, 4. And if I were to write this with a denominator of 4, I would, of course, multiply top and bottom by 4. So that'd be negative 8 pi over 4. And don't let these pi's and 4's and all that stuff psych you out. Basically, this is not really any different from working with, ignore all the things that are the same. This is no different from us working with x minus 1 equals negative 8. It just happens to be a negative 1 pi over 4 and a negative 8 pi over 4. So if it makes sense to you that by adding 1 to both sides of this, you get x equals negative 7, this is the same trip. Because we got common denominators, and because they both have pi, it's the same exact technique. This will be x equals negative 7 pi over 4. Like the pi over 4 is just baggage we carry around, And I'm going to do the same thing with equal to 0 and to 2 pi, but you don't need to watch me do all that stuff, so feel free to pause the video and do it yourself. And this is just me giving you a few moments to pause. So hopefully you're pausing now. And when you unpause, you'll see my work. So quick review of my work here. This blue equation, if I set this inner thing equal to 0, hopefully we just add pi over 4. We don't let ourselves get scared by the pi's and the fractions. They're just numbers. And then we also want to set that inner thing equal to 2 pi. So similar idea. I took that 2 pi. I rewrote it as a fraction over 4. So it's 8 pi over 4. And then in my head, now that I've got these pi's and these 4's everywhere, I'm just going to go ahead and think of this pink equation the same way I might think of the equation x minus 1 equals 8. It just so happens that it's a pi over 4 and a pi over 4 tacked onto both. So that'd be 9, so x equals 9 pi over 4. So these will be the new places for my graph. So I am going to pause the video again, and when you unpause it, you're going to see these numbers on the x-axis, and we will take it from there. So just go ahead and pause, or don't pause, I don't care. At this point, I'm just going to draw some stuff down. So now I've got my 2 separate intervals here. Let's focus on the pi over 4 to 9 pi over 4 first. I'm going to slap the numbers down that I got in the video for, I think it was awkward interval 1. So if you don't know where these numbers are coming from, maybe watch that video, but I can definitely figure out that this halfway point is going to be 5 pi over 4. This halfway of those halfways is 3 pi over 4, and halfway of those halfways is 7 pi over 4. And then in a similar way, this halfway point, actually I got to think about that for a sec. This halfway point ends up being negative 3 pi over 4. That's halfway between these values. And then halfway between these values was negative pi over 4. And then halfway between these was negative 5 pi over 4. So these are the numbers I want to have. And I do want to just, again, keep in mind that this is the one. Let me mark this with a different color. This is the one that was, actually the color I used. This was the one that was at 0. This was the one that was at 2 pi, and this is the one that was at negative 2 pi. So I want my graph to do similar things. So it'll go as high as 1. It'll go no lower than negative 1. This is where the 0 line was, so its cosine goes up 1. It goes down to the 0 line here, back up, and from that 1 down to the 0 line, down to negative 1, back up to the 0 line, back up to 1, and I'm going to try and draw this my very best concave up, concave down, fun. And that's going to basically be it. The trick is just to find these intervals, and all those answers are in the awkward interval 1, 2, and 3. Everything else about this is the same. So just take it one step at a time. Take a breath if you need one. And when you get confused, stop and ask yourself, what exactly am I looking for right now? And I bet you if you can figure out what you're looking for, you'll be able to find it. That's what usually happens, I hope anyways. All right, good luck with this, my friends.